Okay, we are doing section 8.4, which is using scientific notation. A number in scientific notation is in the form c times 10 to the nth power, and c has to be between 1 and 10. It could be 1 and it could be 10, and n has to be an integer. So we're going to change these numbers. These are in standard form. We're going to change them to scientific notation. Now, something to note is if you have positive exponents for scientific notation, you are going to move the decimal place from standard form to the left. If you have a negative exponent for your scientific notation, you're going to move the decimal to the right to get it in scientific notation. So this is from standard to scientific notation. Those are your rules. So if I start wherever the decimal place is, and then I move it until I get a C value that's between 1 and 10. So I move it 1, 2, 3, 4, 5, 6, 7 times to get the decimal between the 4 and the 2. So in scientific notation, this is 4.259. You don't have to put the zeros, but you do have to put all the numbers before that, times 10 to the 7th. Okay, notice this goes with the rule with the positive exponent. For B, I'm going to start where the decimal place is, and then I'm going to move the decimal to get between 1 and 10. 1, 2, 3, 4, 5. 5.74 is between 1 and 10. So our answer is 5.74 times 10 to the, we have to figure out what the exponent is. I moved it to the right, so it's a negative exponent. 1, 2, 3, 4, 5 to the negative 5. Okay, so if you have a negative exponent, you know it's going to be a small number. If you have a positive exponent, you know it's going to be a big number. So now we're going to go from scientific notation to standard form. So if it's times 10 to the 6th, you know it's going to be a big number. So you're going to take that decimal, you're going to move it 6 places. You're going to move it to the right. 1, 2, 3, 4, 5, 6. And for every space that doesn't have a number under it already, you add in a 0. So in standard form, 2, 0, 0, 7, 5, 0, 0, put the commas every 3. That's your number. B, it's negative, so we know it's going to be a really small number. Move it to the left. 1, 2, 3, 4, 5. For every hump that doesn't have a number, we put a 0. So our answer is 0.00001685. Okay, let's try it out here. If we have 539,000 in scientific notation, we start where the decimal place is and move it until we get to a number between 1 and 10, which is 5.39. And we moved it 1, 2, 3, 4, 5 times, and it's a big number, so it's a positive exponent. And then write 4.5 times 10 to the negative 4th in standard form. I start where the decimal place is, and I move to the left. 1, 2, 3, 4. So I'm going to have 3 more zeros. So 0.00045. Okay, now we need to put these numbers in order. The way we're going to do that is we're going to put all of our numbers in scientific notation and then compare the C values and the exponents. So the first number to scientific notation, 1, 2, 3, 4, 5, 6, 7, 8. 1.034 times 10 to the 8th. Second one's already done for us. I'm going to write them all next to each other so we can compare them to one another. The third one, 1, 2, 3, 4, 5, 6, 7. That's 8.076 times 10 to the 7th. So that number, the blue number, is obviously the smallest. I'm going to rewrite it in the form that it gave it to us. Okay, so that number is the smallest. And then we now compare, because the green and the red numbers both have the same exponent, we compare the c's. So the green one has a smaller c, so we know that we're going to write that number next. And then the 7.8 times 10 to the 8th is the biggest one. Okay, so that's what you want to do when you're ordering numbers from least to greatest, is you want to put them in scientific notation, because it's easier to compare it at that point when they're all in the same form. Okay, so now we're going to multiply two numbers that have scientific notation. So what you're going to do is multiply the c's, so 8.5 times 1.7, and then you're going to multiply the two numbers with the exponents. Now we have all of our rules for exponents. That part's not going to be that hard. So 8.5 times 1.7 is 14.45 times 10 to the 8th. And we have to change the 14.45 into a number that is between 1 and 10. So this still has to be changed to 1.445 times 10 to the first. And then we have those two 10s we need to combine the exponents for. So it's 1.445 times 10 to the 9th for our final answer. Okay, B, we're going to use the exponent rule that we learned to distribute that exponent. So it's 1.5 squared times 10 to the negative 3 squared. 1.5 squared is 2.25, and 10 to the negative 3 squared is 10 to the negative 6. Our C is between 1 and 10, so that's actually done. Part C, we need to divide the two numbers and the two numbers with the exponents separately. So 1.2 divided by 1.6 is 0.75, and this is 10 to the 7th. But our 0.75 is not between 1 and 10, so we have to change that. That is 7.5 times 10 to the negative 1 times 10 to the 7th. So combining those two numbers, we have 7.5 times 10 to the 6th. That's our final answer. Okay, let's keep going. Practice. A, we need to square everything. Our answer for this one, I'm just going to write down the answers and you can compare later. 1.69 times 10 to the negative 10. B is 3 times 10 to the 7th. And C is 4.62 times 10 to the 9th. Got one more page with word problems. Blood flow is partially controlled by the cross-sectional area of the blood vessel through which the blood is traveling. Three types of blood vessels are venules, capillaries, and arterioles. Arteries. That's what those are called. I am not a doctor. I am a math teacher, so I cannot pronounce that. A capillary has a radius of 5.0 times 10 to the negative 3. Venule has 1.0 times 10 to the negative 2. And artery has 5.0 times 10 to the negative 1 radius. So if R1 is venule, R2 is capillary, find the ratio. So the ratio of R1 to R2, venule, capillary. We divide the numbers separately and the exponents separately. That's 0.2 times 10 to the 1, which is just 2. The ratio is 2. Let A1 be the cross-sectional area of the venule and A2 be the cross-sectional area of a capillary. Find the ratio of A1 to A2. So the area is just the area of a circle. So A1 is pi R1 squared, A2 is pi R2 squared. the pi's cancel, so we actually only care about r1 squared to r2 squared. The same thing as r1 to r2 quantity squared, and we actually already have the ratio of r1 to r2, which is 2, so the ratio of the area is 4. What is the relationship between the ratio of the radii and the ratio of the cross-sectional areas? It's square. That was the relationship. And that was all for section 8.4.